All right, so week 1 of distance learning here. So we're going to continue on from where we left off before break with conic sections. So we looked at the distance and midpoint formula that last week before break, and now we're going to look at our first set of conic sections. So parabolas, first one, and then the pieces to a parabola, the focus, directrix, latus rectum. We aren't going to really use those two very much, but they will be there. Standard form of a parabola, general form of a parabola. Circle is the other conic section. Center, radius, those are the parts of a circle. So here are the equations for parabolas. It's nothing really, really new except for the second part, the second or third column is whenever it's turned on its side. So instead of being an up and down parabola, it's left and right. So the only changes there are the x's and y's swap places and the h and k swap places. Otherwise, everything stays the same concept. So if it's inside, like the k is, then our vertex is the opposite sign of what it is. So right now it's minus k. The vertex y value is a positive k. So whatever k is being subtracted, right? These other things help you find out those pieces. So the directrix, latus rectum, focus, all of these things can help us find out what those pieces are. So what a is, or what h is, or what k is, just depending on what's given to us. So our first one, we just want to turn it into standard form, which in this case for conic sections, standard form instead of the form it's in right now. This technically is standard form for a quadratic, but for conic sections, standard form is vertex form. So we need to switch it up. So if you remember back to when we looked at quadratics, to get it into vertex form, we had to complete the square. So what we need to do is group our x's together. So we're going to leave the y alone, and we're going to factor out a negative 1. So it's x squared plus 2x, and then plus 3 outside. So we're going to complete the square inside the parentheses. So we're going to add some blank number on there. And on the outside, we need to subtract because we're adding inside. If they're on opposite sides of the equal sign, then we would add instead of subtract. But they're all on the same side of the equal sign, so we have to subtract now. And we have to multiply it by the negative 1 that's out front, too. So we can't ignore that negative 1 that's out front of the first parenthesis. So now we need to figure out what our blank is. That's going to take the 2 that's in the middle of our quadratic, divide it by 2, and square it. Well, 2 divided by 2 is just 1, so 1 squared is 1. So both of our blanks are 1. So now our large parentheses is a perfect square trinomial. So that means it's y equal to a negative 1 times x plus 1 squared. And then all the numbers outside, so the negative 1 times 1 is negative 1, but it's minus that, so it's adding. 3 plus 1 is 4. So there it is in standard form. Now it asks us to find some other things too. The vertex is easy because it's given to us in the equation. So our vertex is at negative 1, 4. The axis of symmetry is just x equal to whatever the x value is for the vertex. Now if this was going the other way, if this was a x equal to y squared, or negative y squared, then it would be whatever the y value is for the vertex. So it just kind of depends which direction it's opening. So it's just x equal to negative 1. And it also asks us for the direction of opening. So because the negative is out front, the direction is opening down. So there's the other 3 things it asks us to find. So now our first one we want to graph. So we only have a very small table here because the only thing that's changing between this and the parent function for quadratics or for parabolas is just the 2 out front. So we're just going to put a negative 1, 0, 1 in our table. And so then we have 2 times negative 1 squared. Negative 1 squared is 1, so it's 2 times 1. which is 2. 0, 2 times 0 squared. 0 squared is 0, so 2 times 0 is 0. And then the 2 times 1 squared. Again, 1 squared is 1. So that's also at 2. So graphing this, we are at 0, 0 at the origin. Which makes sense because it's not being shifted or compressed, or not shifted, sorry. It is being stretched, not compressed either. So over at 1, we're up at 2 in both directions. And now if we wanted to keep going, we could. We can fit that. So if we went over to 2 on a normal parabola, it would go up to 4. This one's going to go up to 8, which is the top of my graph. So now connecting, when we get to circles, I have a nice tool that does this for me, but I don't have that here for parabolas. So there's our parabola. So notice it does say graph this function. So parabolas sometimes can be functions. The other conic sections are never functions, but parabolas can be sometimes, only if they're going up and down. If they're going left and right, no more function. So this one again is opening up and down. I know that again because it has a y equal to. And then the 2 out front means it's opening up. So we have a little more process to go here, but we're going to start. So first, we know the vertex, because it's in vertex form, is at 1, negative 5. So that's 1 point already we know without having to plug anything in. So we can skip that when we're doing our table. So we're going to start with negative 2, negative 1, 0, but we're not going to do 1 because we already know that. So 2 and 3. So plugging these in, 2 times negative 2 minus 1 squared minus 5. Can't really fill much more in there, but let's go through there and actually do the math. So negative 2 minus 1 is negative 3. Negative 3 squared is 9. 2 times 9 is 18. 18 minus 5 is 13. That's off of our graph, so we can't really use that. 2 times negative 1 minus 1 squared minus 5. Negative 1 minus 1 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. That's on our graph. Then for the 0, 2 times 0 minus 1 squared minus 5. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. And 2 minus 5 is a negative 3. Now we're skipping the vertex, so hopefully we know that the next one should be a negative 3 as well. So 2 times 2 minus 1 squared minus 5. 2 minus 1 is 1. 1 squared is 1. 2 times 1 is 2. 2 minus 5 is negative 3. And we should get a 3 for the next one. Three minus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. So the next one would be 13 if we went up to 4, but again, that's off of our graph, so that doesn't really matter to us. So we can go ahead and start graphing these. At negative 1, we're up at 3. At 0, we're down at negative 3. Jumps pretty far down. And then we're at negative 5 for 1. There's our vertex. Go back up. And here go my wonderful graphing and drawing skills. There we go. It's actually not bad for me. There's our parabola. So this next one is not in standard form. It's in general form right now. We need to change that. And we already can tell that since the y is squared, that really isn't a function. It shouldn't say graph the function. So we need to move that over. So we have y, or x equal to a negative y squared plus 4y minus 1. Then we need to factor out the negative and separate out the y's. So it's negative 1 times y squared minus 4y minus 1. Now we're going to have to complete the square. We're out of space there. Should have wrote smaller to begin with. That's all right. Oh, we need to figure out what goes in the blank. So we take the negative 4, we divide by 2, and we square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So that's what goes in both of our blanks. So x is equal to -1. Our parentheses is a perfect square, so that's going to be y minus 2. We just take this number and put it there, squared. And then we have a -1 times 4, that's -4. Negative 4 is +4, so -1 plus 4 is +3. So now we know it's opening to the left because of this negative. +1's open to the right. Our vertex is at 3, 2. And then everything else just follows the normal pattern for a parabola. So we're going to graph it. So at 3, 2, there we go. And it opens to the left, so we're going to go up 1 and to the left 1. And then from our vertex, up 2 to the left 4. And that's all we're going to be able to fit on this graph, unfortunately. Almost could do another one, but can't quite fit it. So now my drawing skills are really going to be tested going sideways. Not too bad. There's our parabola. First sideways one. So this next one, you can see x is being squared, so this one's going to be opening up or down. So this kind of depends on what we get for our a value. So we need to shift things over. Everything but the y needs to go over to the other side. So that's going to be y equal to a -2x squared plus 8x. And we subtracted a 10 over, so that's going to be a -5. So again, we're going to complete the square, so we need to factor out a -2. Now we're ready to go ahead and complete the square. See if I can write smaller than the last one. Again, making sure we include our -2 that's out front of our other parentheses, otherwise something's going to be wrong. Oh. Keep forgetting, now we need to find our blank number, which conveniently is actually the same as it was last time. So -2 squared, or 4. So y is equal to -2 times x minus 2 squared. And so the outside, -2 times 4 is -8. -8 is +8. -5 plus 8 is 3. So again, we know it's being stretched now by a factor of 2. So when we go up, we have to go up 2 times what we would normally. It's opening down, actually, so going the other way. And then our vertex is at 2, 3. Again, it opens down, stretch vertically by 2. So at 2, 3 is where we're starting. We're going to go to the right one down 2 instead of 1, which is normally what we would do, and to the left one down 2. We would normally go to the right 2 and down 4, but now we're going to go down 8. And that's all we're going to be able to fit on our graph. Got a little wonky on that side there. There's just about what the parabola looks like. So this one's here is different. We have the vertex and we have the focus, so we need to graph it from that. So again, our vertex is at 8, 6. So all the way over here. It says the focus is at 2, 6, which is right here. So you can see that the focus is to the left. So that means that's the direction we're going to open towards. So we know that already. We also know from the equations from before that the focus for this situation is going to be equal to h plus 1 over 4a k. So our h we know is 8, k is 6. So we plug those in. Really don't need to worry about k so much, but our focus, we know that the h plus 1 over 4a is equal to 2. So that means we have 8 plus 1 over 4a equal to 2. If we subtract 8 from both sides, we get 1 over 4a equal to a negative 6. So 4a is equal to 1 over negative 6. We multiply both sides by 4, and a is equal to a negative 2/3. I just realized I did that wrong. So that part was right. But we're going to divide by 4 on both sides, so you end up with a equal to a negative 1 over 24. That's what a is. So that goes out in front of our equation. We also know our vertex already. So that means we have the equation. So I'm going to write it pretty small here, but it's going to be x equal to a negative 1 over 24 times y minus 6 squared plus 8. So there's our equation. And to graph this, it's being stretched pretty crazily here, so it's going to be pretty narrow. So I'm just going to kind of sketch it here. It's going to be something like this, both directions. There it is. So you can kind of ignore that middle part, though. That's the part we used earlier. There's our graph. So this one here, we have a real-world example. So a couple things are happening here. You're given the height of the arch, so that means our vertex is at 0, 25. And the focus is at 0, 18. So that means this one's going down. So now we are, again, looking at the same idea as the last problem, looking at the focus part of it. So again, we know that since the 0 is the same for both of our vertex and focus, that doesn't really matter. But the y value is changing, means that our focus is at k plus 1 over 4a. So that 18 is equal to our k, which we know is 25, plus 1 over 4a. So 18 equal to 25 plus 1 over 4a. So we subtract 25 from both sides. That's going to get us a negative 7 equal to 1 over 4a. And so 4a is equal to 1 over negative 7, or a is equal to negative 1 over 28. So in the previous one, that fraction made it compress to be, but it's still compressed vertically. No matter what, it does that. So it made it really narrow. This one's going to go the other way. It's going to get wide. So it's y equal to that negative 1 over 28 times x squared. We don't really have to have the parentheses, actually. And that's going to be plus 25. That's our equation. So now graphing that, we're going to skip by 5s here. So we're up at the very top of our graph for the vertex. We're missing some points, but it is being stretched by quite a bit. And unfortunately, we don't really get anything that's pretty through this graph. So over at 5, we're up at 24.1. At 10, we're up at 21.1. 4. So that's just above the third line up. So I'm just going to do a few of these just to kind of get an idea. And if we go at 20, we're at 10.7. So really just above, just above this line. Wait. Oh. So those ones weren't right. Right here. Right here, above the fourth line. Sorry about that. Now, 25, we're at 2.67, so it's just above the bottom. So we're not really seeing where the arch hits the ground, but there's our graph. So now circles, a little bit different. Circles, you square both x and y, but really they're actually not too complicated because there's only a few things that happen. And really you have both versions right here, where the first part is centered at the origin, the second part is not centered at the origin. So the center of the circle is hk, and our radius is the what's on the other side of the equal sign squared, or well, square root of whatever is on the other side of the equal sign, unless it's already written down in a squared. So the plan for a park puts the center of a circular pond of radius 0.6 miles at 2.5 miles east and 3.8 miles south. So what we want to do here is just come up with the equation for it. And the headquarters are at the origin. So that means our center is a y value of negative 3.8, or k, I guess, actually. And an h value, because that was south. And east is positive in the y, or in the x, 2.5. And our radius is 0.6. So again, our formula for this, x minus h squared plus y minus k squared equal to r squared. So that's x minus 2.5 squared plus y. Since that's negative, we're going to change it to plus 3.8 squared equal to 0.6 squared. And we're going to go ahead and square that 0.6. Actually, we'll leave it like that. That's fine. It'll be 0.36, but that's fine. So our next one, we are given the graph. We're given the center is at 0, 3. Our radius is out to 7. So 0 to 7 is a radius of 7. So we have everything we need. So our equation again, our formula, x minus h squared plus y minus k squared equal to r squared. So x minus h is going to be 0. So that's just x squared. K is 3, so that's y minus 3 squared equal to 7 squared. And again, I'm not going to bother squaring the 7. 7 squared is 49. So this next one here, we want to write the equation of a circle if the endpoints of the diameter are 2, 8, and 2, negative 2. So we have a diameter now. We want to find the radius from that. So what we have to do is, we have a couple options. So I would find the midpoint. That will tell us where the center is. So that's going to be 2 plus 2 divided by 2, and 8 plus negative 2 over 2. So that's going to be 4 over 2, 6 over 2, or 2, 3. So that's our center. So now from these, notice all of them have the same x value. So that means it's along the same line. So our radius, or the diameter length, is equal to 8 plus negative 6, or negative 2, So really it's negative 2 minus 8 over 2. Or you just do 8 plus 2 over 2. No, not over 2. Just 8 plus 2. Sorry. Having a little brain fart. So that's 10. Radius is equal to the diameter over 2. So 10 over 2, or 5. So the equation, again, x minus h squared plus y minus k squared equal to r squared. So that's x minus 2 squared plus y minus 3 squared equal to 5 squared. And again, you could square the 5. I'm not going to deal with it though. So this one's actually kind of easy because our equation shows nothing being added to x or y, which means their center is the origin. So the center is at 0, 0. Then the radius is going to be the square root of the 16, or 4. So we just go out 4 from the center of the origin in all 4 directions. Now I have a nice little tool that I can make a perfect circle with. And there it is. Super easy. So our last problem, number 10 here, not quite in the format we need it to be. So what we have to do here is actually complete the square with the x's. The y, there's only one y, so we don't have to worry about it. So we're going to have to move that 7 over. And group our x's together. So we have x squared plus 6x in parentheses plus y squared equal to 7. So completing the square means we've got to add something into the parentheses and on the other side the equal sign. So x squared plus 6x plus something there plus our y squared is already good equal to 7 plus that mystery number. So taking our 6, dividing by 2 and squaring, completing the square, gets us 3 squared, or 9. So now we have a perfect square trinomial. So that is x plus 3 squared plus y squared equal to 7 plus 9 is 16. So the square root of 16 is 4. So x plus 3 squared plus y squared equal to 4 squared. So our radius is 4. The center is at -3, 0. So there's our center. We go up 4, to the right 4, to the left 4, and down 4. Make our circle. And there it is. And that's our video. See you next time.